Okay, welcome back. We're talking about bare metal. So bare metal means I don't have to have an operating system on the machine at all. I can buy it without an OS. Um, I don't have to worry about installing the server and doing an activation, burning an activation key that I don't need because I'm just going to take this machine, not even look to see what's on it because I don't care. And I'm going to partition it the exact same. When you do the recovery, it'll come up and say, "Hey, you want to keep the partitions just the way they were?" I mean, you might go, "Well, no, let's stretch this out a little bit because I got a little bigger drive, and maybe I'll scoot this over a little bit." You can make some little tweaks to it, but then it's fire and forget after that. You push the button and it installs everything, and when you're done, you just reboot and go on about your business. And so, obviously, bare metal is faster because I can just take a naked machine with no operating system on it whatsoever and in one step get everything going. Now, Acronis has a thing called Universal Restore, which basically is a package of practically every driver in the world, so that when your machine boots up, it'll be able to hit wherever the backups are, like with a tape drive or through a NAS or a SAN or over the network. So it has to be able to find the network drivers. Now, if you have a very, very, very specialized stuff like a robotic tape drive, you might have to build a restore disk yourself so that when you bring it to the new machine, it'll have the driver for, the piece of hardware that you have. Anyway, it's just a step that you have to do. Whenever we have a brand new server, that's one of the things we do. We build a disaster disk, stick it away and hopefully never ever use it. Okay, so bare metal is faster because I don't have to install anything before I start to restore. Okay, so what to back up? You could think, well, there's no need for me to back up the operating system and all the programs on the C drive. Well, yeah, you do. If your server caught on fire, the amount of time it would take to go through and first of all, remember what was installed there, and then install the software and maybe configure it. I mean, oh my God, who had permissions on this? It's just too complicated, too much work. So it makes sense to go ahead and have the backup do the operating system and all the programs, basically like the C drive. Consider that bare metal works great for this, but you don't have to back that up very often, all right? I mean, once a week would probably be perfectly okay. Now, user files. So let's say it's with a file server. Drive C is where all the operating system is. Drive D is where people put their, file shares and they dump stuff to it. So user files only, which in this case would be the D, you could do a file backup at this point, or because image backup basically says, oh, this partition, but not like this folder. I mean, you could do that, but file base is really designed for, let's say, here's another example. Let's say you've got 10 terabytes of data, but you only have 5 terabytes of removable drive. So you put one of the drives in and say, okay, I'll take these directories, boom, 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 and they go up to the backup. And then after it's done, you put in the other one and you say, I'll take these, boom, 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 boom. So file works really great if you have limited capacity and you don't have a robotic tape drive. And it will allow you to do a version. You could do continuous versioning. You could, and that's kind of cool. Maybe you want to do both, okay? Maybe you want to have continuous versioning, but a relatively short amount of space involved. I mean, not like equal size. Like if you have 10 terabytes of shared files, I wouldn't put 10 terabytes of file storage. I probably would do 2, okay? But then I would back up everything. So in addition to having file versioning, which is a very cool feature, particularly if the people can go get files themselves without having to ask, without having to send a trouble ticket or call on the phone, they could do it themselves. Oh, in my world, I don't have file versioning turned on, but you just do a right click on the file and it says previous versions, and you pick the one you want. I mean, that is fantastic. I can do it all by myself. I don't have to have IT. I love that feature, but don't count on it being a backup strategy. Okay, so backup types. Now, this is kind of a term that's used with tape backups because most of the time image backups, you don't do this, but you could. So a full backup means copy everything And then a differential is only the things that have changed since the last time you did a full backup. An incremental is everything since the last whatever, full, diff, or increment. And often you use a mixture. For example, you might do a full backup over the weekend and then do differentials or perhaps incrementals each night. So this is what this thing looks like. So this is just a diagram. And what this unit over here is, I don't know, tapes, time, something, effort. So you could, one of the strategies is if you did a full backup every single day, well, it would take, 20 minutes to do. Again, I'm not really specifying what this unit is. 20 minutes to do every single night. It takes exactly the same amount of time. Now, the full plus diff, the first one's going to be big, but the second one's not. And this was only going to be the changes since Sunday. And this is going to be the changes since Sunday. And this is going to be changes since Sunday. And so it might grow a little bit because you're, during the week, you're adding stuff. Incremental means I'm doing a full on Sunday and only those things that have changed since Sunday. This one is only those changed since Monday. This one's only the change since Tuesday. So you can clearly see that full takes the most amount of effort. Incremental takes the least amount of effort. Now, if you're talking about tapes, okay, so incremental is going to take the most amount of tapes, right? Lots of tapes. Like when you got to Saturday, if there was a problem on Saturday, what you would have to do is do the full, and then the Monday, and then the Tuesday, and then the Wednesday, and then the Thursday, and then the Friday. Now, let me tell you, if you don't have a robotic system, we're talking about putting in a tape, letting it run. When it stops, you put in another tape, let it run, and it stops, and you put in another tape. So basically, you're glued to the server room. You can't leave because you have to wait until the tape drive stops to put in another tape. That is a pain in the butt. Plus, it's just infuriating because you're stuck there. Now, if you're doing a differential, then you're talking about two tapes. I put in one tape, wait for it to run. Put in the other tape, wait for it to run, and then you're done. If you do a full, you put in one tape and you walk away. Now, let me tell you, there's some advantages in walking up to a server, putting in a single tape, hit the restore, and then get up and walk out the door and go talk to the boss and say, here's what's going on. Because you're no longer glued to the server room swapping tapes out because there is only one tape. So which of these types is the quickest to perform a backup? Well, quite frankly, it'd be the incremental. Which one uses the least amount of tape media? Well, again, incremental. Which one gets bigger each time? Well, that would be the differential. Which is the type that's quickest to perform the restore? Ooh, now here's the thing. This is a thing you really need to be paying attention to. This is the guts of this discussion. You should optimize your system for restore operations, not backup operations. Nobody cares how long it takes to do a backup. Nobody cares. It's done in the middle of the night. Nobody cares. But everybody is going to be screaming and hollering when you're doing a restore. So you need to optimize the restore, which means you probably, if you can get away with it, if you have enough storage and have enough tapes, go ahead and just do a full backup every day. Just bite it, so to speak, and say, I'm making this problem go away. No, it is not quick, but who cares for backups? Because nobody cares how long it takes to do a backup. And everybody's going to be pounding on the server room door while you're trying to do a restore. And you don't want to be stuck there. Okay, so rotating the media. Don't you reuse the same disk over and over again. That's kind of dumb. And this does require an awful lot of spares. And then you have to retire. A disk or a tape don't last forever. And then you're going to have duplicate hardware. Like, for example, when we had the robotic drives. By the way, the robotics drive tape drive system, an LTO, was not all that reliable. We come in the morning and go, dang, that thing's stuck again. But we had two of them, okay? Because if one died, we needed another one. And then you got to store the media offsite. Obviously, it'd be really great if you had a secure storage facility. Okay, cloud-based. So what's wrong with a cloud-based answer? Here's the thing. If you're using this in a disaster recovery point of view, a tornado went through and wiped out your building, what is the likelihood that the internet's going to be available and stable during that same disaster? I don't know. I wouldn't count on it. And then, a lot of people, like at home, you might have, gigabyte download speeds, but only like 100 meg going up. Okay, so asymmetric. A lot of services, particularly for home, have a different upload speed than download speed. So let's just assume that your upload speed is 100 megabit, which is dang fast, right? So I have 4 terabytes of data and I want to send it up at 100 megabit. How long is that going to take? 88 hours. It's going to take more than 3 days to copy that up. Is that a viable backup and restore option for you? Probably not. RAID. So this is all about how to make things more secure. So redundant array of independent used to be inexpensive disks. And there's 3 types, a stripe, mirror, and parity. Often I have a RAID-based NAS box, and I'm using RAID 5 parity, and you can have a spare drive or 2 in there. And it's all about design for fault tolerance. That's what it's mostly about. So RAID 0 just means I type Mary Hatta goes to one drive and little M goes to the other drive. It basically splits the data and puts it into 2. Makes it incredibly fast. But I've actually increased my risk of drive failure, because if one of the 2 drives fails, I got nothing. RAID 1 is a mirroring. Everything you're written to one gets automatically written to the other. That's fantastic. It's great for storage, and the speed is the same as having just one drive, but I get fantastic replication, and therefore the likelihood of having a single drive failure cause me a problem is like 0. The problem is not scalable. I mean, if I used RAID 1 with 10 drives, that would be 5 drives over here and 5 drives over here. That's an awful lot of wasted drives. So RAID 5 use this thing called statistical parity. I'm not going to go into technical details, but what it basically means, it splits the data over multiple drives, but I don't have to have I can just have one drive handle the spare activity. So if I have a single drive that fails, I'm okay. If I have 2 drives that fails, I'm not okay. But that's what RAID 5 is. Here's basically a picture. Striping basically means everything goes to disk 1 and disk 2. Mirroring basically means this block goes to that block. This is block 1, block 2, block 3. So this is fast, very fast. But if any drive fails, I'm in bad shape. This is great. And then RAID 5, and then a combination. You can have a combination of striping and mirroring. Okay, you can have a 10, 0 and a 1, or a 5 and a 0, those kind of things. Okay, so here's basically the guts to this thing. A RAID 0 stretches the data across the drives. The minimum number to build a RAID 0 would be 2. And the capacity is the sum of the disk. Is it fast? Yes. Protection? None. In fact, if anything, it's worse. Duplicate? 2. The sum of the disk divided by 2. Okay. Very good protection, and it's just as fast as a raw drive. RAID 5? That statistical duplicate thing, the minimum would be 3. Most of the time it'd be a lot more, like 5 or 6. It's the sum of the disk minus 1 disk. If I had 10 disks, the capacity would be 9 disks worth of capacity. Okay, cool. RAID volume size. This is an example. Let's say I had 6 drives at 2 terabyte each. What would the storage be? Well, if it was RAID 0, it'd be all of them. If it was RAID 1, it'd be half of them. If it was RAID 5, it'd be 1 minus that. Okay, we're coming up on the 15-minute mark. You guys know how this works.